Happy today, whatever day it is that you're watching this. I hope you're all doing spectacular. And we're going to talk about solving system of equations by substitution. Because with my great handwriting, you could tell that that says substitution. Because as I look at it, I'm like, what did I just write? I know what it says, but now you know too. So we've been talking about when two lines cross. You take one line, you take a second line, and they cross over each other. We want to find where do they intersect. Well, we did it by graphing already, so you physically saw the representation of it. Now we're going to do some where it's not always, we're not always going to graph them. So we're going to solve them algebraically, and there's two ways to do it. Substitution, which is what we're going to focus on today, and elimination, which is a separate day of notes. So substitution, we have a couple of steps. You have a system, means two or more. Okay, so here's our two or more equations. Usually it's going to be two almost every time. When we have that system, the first thing we want to make sure we do, and I'm going to give you a little hint, I think almost all of your problems, maybe except a few, will already have this step done, but you want to, if necessary, I'm going to put I dot n, if necessary, solve for one of the variables in one of the equations. That's it. So solve for one of the variables in one of the equations. Okay. The second thing that we want to do then is we are going to do what this is called. We are going to substitute in the other equation and solve for that variable. So let's go back here. So we already have step one done really in two different ways here. I already have y equals x minus 2 and y equals 4x minus 11. So both of these are already solved for y. So what I'm going to do is I'm going to take one of these y's, which equals x minus 2, and I'm going to substitute it in over there. Just like if I said y is 7, you could plug in y is 7. Well, instead of plugging in 7, I'm going to plug in x minus 2. So now I have x minus 2 equals 4x minus 11. So I did that part. I substituted in for y. Instead of saying it's y is also equal to x minus 2, so I substituted that in. So if you think about this, we said we want to know where they cross. Well, when they cross, those two lines are exactly the same for 1 point. We're finding that 1 point. So in this case, I'm going to solve, it says, for that variable. In this case, that variable is x. So I have variables on both sides. I'm going to subtract x from both sides. So I get negative 2 equals 3x minus 11. I now have just x on one side, so I add 11. We get 9 equals 3x. We divide by 3, and we get x is 3. But we're not done. We want to know where these lines cross. Well, lines cross at coordinates. Okay? At a point, I should say. At a point, we write it as a coordinate. So that's our third step. Once you solve for one variable, so in this case, we've solved for x, you substitute the solved variable into one of the two original equations. And then lastly, I'm going to put this as a step. Write your answer as an ordered pair, and I'm going to put in parentheses, unless a special case. We do have special cases. You can have parallel lines where they never cross, or you can have lines that are graphed on top of each other where they cross everywhere. We're not going to get to those right now, though. Okay, so I'm now going to take this 3, and I'm going to plug it into either one of these two. It doesn't matter. I'll show you both give the same answer. So if I go to the top and I plug in x is 3, 3 minus 2 is 1. So it lets me know y is equal to 1. If I did it here, 4 times 3 minus 11 gives you 12 minus 11, which is also 1. So it doesn't matter which one you choose. Okay? So now I have, though, my two answers, or my two points for the coordinate. Whoops, that's a 1. So I write it as an ordered pair, 3, 1. So that's my final answer. Where do these two lines cross? They cross at 3, 1. How do I know? I use substitution. I solve for one of the variables in one of the equations. I substitute it in for, I solve now because I only have one variable in there, x minus 2 equals 4x minus 11. I solve for x. I got it's 3. I got to plug back into one of the original ones. Difficult? No. We got to follow the steps along. But there's nothing in here that's mind-blowing or new. We're taking, like we tend to do in math, different pieces and putting those pieces together. Okay? All right, let's take a look at a couple examples now and go through. So I have y equals 2x minus 10 and y equals negative 2x plus 2. Okay? So lots of beeping on here. Let me turn some stuff off. I already have them, step 1, solved for one of the variables. So like I said, that's an if necessary. It's not going to be very often necessary. Step 2 is substitute one of these in for the other. Now, in these, it really turns into, I just really set them equal to each other. But if I think of what I did, I took this and I substituted in for there. Y is equal to 2x minus 10. Okay, thank you. Well, then I'm going to replace in this equation, y is now becoming 2x minus 10. It still equals negative 2x plus 2. And I solve. So in this case, careful, they look almost the same, but I have a positive and a negative. So I have to add 2x to both sides. I get 4x minus 10 equals 2. I add 10 to both sides, so I get 4x equals 12. We divide by 4, and x is 3. That's only part of the answer. I still need to plug that back in into one of the original two. I'll do the top one, or I'll do the top one again. So y equals 2 times 3 minus 10. What's 2 times 3? 6. 6 minus 10 is negative 4. So y equals negative 4. So what's my final answer? Write it as an ordered pair. That's step 4. 3, negative 4. Okay. All right, let's take a look at one more like these where both are already solved. So let's say I have y equals x and y equals negative 3x minus 8. So step 1 is already taken care of. Both are already solved. I'm going to take then step 2, y equals x. I'm going to take that x and substitute it in for y in the second equation. So it really comes down to, I just set these two equal. X equals negative 3x minus 8. I solve for x. I'm going to add 3x to both sides because then I don't have to worry about negatives. So I get 4x equals negative 8. We divide everything by 4, and x is equal to negative 2. Are we done? No. Good if you said no. Now I plug back into one of these two. I might be like, if I plug back in for x, it says y is negative 2. Yep. Those are sometimes the more confusing ones, but that's your answer. It's just negative 2. So my answer is negative 2 for where these two lines cross. Okay, so going back again to that original, how do we do this? You need them, one of them equal to y or x, so that you could substitute into the other equation and solve for that variable. Then whatever you get for an answer, you take that and substitute back into one of the original equations so you get the opposite variable. And I'm going to star this one. This is where people get a lot of easy ones wrong. Write your final answer as an ordered pair. Don't tell me x equals 3 is your answer. Okay? You need an ordered pair. It's where two lines cross. You have a great day. We'll see you next time.